Hello, welcome to my channel. In this episode, as episode 2, we are continuing with the relation and function. In this episode, we are going to treat function as the concept of function. From the first episode, we did mention that a function is a special kind of what? A relation in which an element from the domain has only one image, or simply put, one element from the codomain. That is, element from the first set should always have only one element in the second set. That is a function. And we did also mention there are two types of function. Comparing it with relation, we have one-to-one relation being one-to-one function, and many-to-one relation also considered as what? Many-to-one function. Good. So if we can consider two sets, as in set X and that of set Y, normally we use the circle to indicate. If we place an element X and an element Y, this relation is what we are calling a function, whereby an element in the first set has only one relation in the second set. The first set is what we call the domain. Then the second set is what we have as the codomain. Good. Now, this is the object that we have. We have each relation or mapping to the next set. So the element Y become the image. So Y is the image of the point or the element what? X. So in function, we can rewrite this in terms of notation as f x. That's what the function from x to y. The function from x to y, which could also be written as the f of x, or we can say the image, the element x under the function f. So now we also we did mention of the term range. So in some places we can say domain, codomain, or domain and range. What is the difference between a codomain and a range? Now, a range is a subset of a codomain. If you are referring to a range, it means you are referring to an element or image that has mapping from the codomain, from the domain. For example, if we have this as the set X and set Y. Now, if you are asked to list the element in the first set, our element in set X is going to be A, B, C. Then the element in the set Y is going to be 1, 2, 3, and what? 4. Now, this is what we are calling the domain. This is what we are calling the codomain. Then the element that have mapping from A or from X will be 1, 2, and 4. So this become the range. So we can say that the range is a subset, as you can see, 1, 2, 4, 1, 2, 4. The range is a subset of the codomain. Now there are instances whereby the domain, the codomain, and the range will be the same, as in this case where I have C and D. This is one-to-one function or one-to-one relation, whereby A1, B2, C3, D4. That is the ordered pair. When all the ordered pair are picked and the element we have in the codomain is the same element we have in the range, we can call each of them. We can use the domain as the first set, we can use range as second set, or we use domain as first set, then codomain as what? The second set. All right. We can also write functions as an equation, as in we know y equals to the f of x, as in this, or the f of x equals to the value given to us, which will be 3x minus 1. Now, if we are having this, then we are saying that if y equals to f of x, then the f of x could also be equals to y. Don't forget, we know that the y is standing in for the codomain, then the x is standing in for the domain. So if I've been given a function in this form, I can be asked to find the image of what? The domain. When I mean the image, I mean individual mapping of a particular element. So for example, if I've been given a domain as in, and I'm asked to find the image of each of the elements, or to find the range of this function, it means that I am going to replace the x. Don't forget, this is going to be a set of 0, 1, 2, which is the x. Then we have y. We are looking for the image. What is the image of 1? 1 is mapping to its value, but we have been given the function already as what? 3x minus 1. So what I need to do is replace the value of x by each of the individual elements. So in this case, I'll be having f of 0 equals to 3x, where the x is no more, but now 0 minus 1. So that will give us minus 1. Since this is 0, then this is also going to be 1 equals to 3 of 1 minus 1. And that will be 3 minus 1, which is equals to 2. Then finally we have f of 2, which will be 3x. The x is now 2 minus 1. And that will be 6, which will be what? 5. Meaning this is going to be minus 1, 2, and 5. So if this is what we have, this could be our one-to-one relation. So any function given to you, this is the image of 1. Finding the image of an image of 0 is what? The minus 1. The image of 1 is 2. And the image, don't forget, these are also the image. Putting together as a set become the range, or become the codomain. But each individual element, from here, it will be the object or a point. Then we have the image. So if we have f of x, or better still, x, that map to x plus 1, x minus 1. If you have this, we can also be asked to find the image of each individual domain under this. So you only have to substitute the value of x with that object or with that point, then you can generate the value for each image. I believe the concept for function is clear. The next, we'll be taking the various type of function, which will be one-to-one function, how to prove a one-to-one function, and what is many-to-one function. Come back to this space for the continuation.